Welcome back. In this video, we are going to solve problem 7-6 that is taken from chapter number 7, Internal Forces, and book name is Engineering Mechanics, Statics and Dynamics by R.C. Hibbeler, 14th edition. Statement is determine the distance A as a fraction of beam's length L for locating the roller support so that movement in the beam at B is equal to 0. So this is overhanging beam. Here we have roller support at A and there is a pin support at C, and there are 2-point loads, one at the end and other at point B. Clear? And we have been asked to find this distance A as a fraction of beam so that to locate this roller support such that movement at B is equal to 0. So let's start with the solution. The first step is that if you remove this roller support, so you will be having a vertical reaction force. Let this is Ry, and if you remove this pin support at C, so you will be having vertical reaction Cy, as well as there is a horizontal reaction Cx. Okay, so what we are going to do is that we are interested to find out Cy because we have to find the moment at this B. So what we are going to do is we will find Cy. So for that we will apply equation that sum of all moments about point A is equal to 0 and taking the counterclockwise movement as positive. So about point A, the first movement will be due to this load. About this point, first movement is due to this load P and perpendicular distance is A and it is producing counterclockwise movement, so it will be taken as positive. So I can write it as P multiplied by A. The second load that is producing movement is this Cy, and the perpendicular distance will be this one. And you can see this distance will be equal to, total is L and this is A, so this length will be L minus A. So I will tell you that Cy into perpendicular distance is L minus A is producing counterclockwise movement which is positive. So I can write it as plus Cy into L minus A. The last load that is producing movement is this P and perpendicular distance is this one, which we will get. How we will get it? That you can see that this total distance, this distance is L. Clear? So the remaining this distance will be equal to L minus L by 3. L minus L by 3, and then we will remove this A. You can see that this distance between these two P is how much? This is total is L minus L by 3. So L minus L by 3 is how much? If you take LCM, so this will be 3L minus L is equal to 2L by 3. And distance from this to this, it will be equal to, this is actually 2L by 3. So if you subtract A from this, so this distance will be 2L by 3 minus A. Okay, now you can see this force P into perpendicular distance is this one is producing clockwise movement, so it will be negative. So I can write minus P multiplied by 2L by 3 minus A is equal to 0. Okay, we are interested to find out Cy. So Cy into L minus A is equal to P into 2L by 3 minus A minus PA. Okay, so P into 2L by 3 minus PA minus PA. So here 2PL by 3 minus 2PA. So if you take 2PA common from it, so you will get 2P common, so we will get L by 3 minus A, and that is equal to Cy into L minus A. Okay, so Cy will be equal to 2P into L by 3 minus A divided by L minus A. This is the value of Cy. Once you get this Cy, so what we are going to do is that we will section this beam at point B and we will draw the free body diagram, because we have been asked that moment at point B is equal to 0. So here Cy is how much? This Cy is this one, clear? And Cx is equal to 0 because there is no horizontal force, so Cx will be equal to 0. So when you cut it, so you will be having a normal force N, you will be having a shear force V, and you will be having a moment M at point B. And there is a P force also acting at point B. Okay, the distance from Cy till B is given as L by 3, clear? So we will apply equation of equilibrium that sum of all moments about point B is equal to 0, and taking the counterclockwise moment as positive. So about point B we have the moment is this Cy into perpendicular distance is L by 3, and it is producing counterclockwise movement, so it will be positive. So I can write it as Cy multiplied by L by 3, and this internal movement which is also clockwise, their sum must be equal to 0. Now we have this M will be equal to Cy into L by 3. The value of Cy is 2p into L by 3 minus A divided by L minus A into L by 3. This is the equation at moment. But we have given that we have to find this distance A in order to have movement at B is equal to is 0. So what we are going to do is that we will make this M is equal to 0. So 0 is equal to 2p into L by 3 minus A divided by L minus A into L by 3. If you multiply this 3 into L minus 3 on both sides, so we will get L minus A into 3 is multiplied by 0 is equal to 2p into L by 3 minus A divided by L minus A into L by 3 multiply by L minus A into 3. So this will cancel with this will cancel with this, and here we will get this 0 is equal to 2p into L by 3 minus A into L. Okay. Now we will get this 2pl into L by 3 minus A is equal to 0. So if you divide both sides by 2pl, here 2pl. So this will cut with this, and we will left with L by 3 minus A is equal to 0. So from here we will get this A is equal to L by 3. Okay. So this is the answer that we will be having. We have to locate this roller support at a distance of L by 3 from this side, so that moment at point B is equal to 0. And that was all about this problem 7-6. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it, and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Thank you for watching.